As we saw in the last module, a restriction digest is the first step in molecular cloning. This module will go over restriction digests in more detail. This is the plasmid map of PUC19 that we saw in the first module. Recall that a restriction digest is done in the multiple cloning site, or MCS, which is an area of concentrated restriction enzyme cut sites. When doing bacterial cloning, you may choose to cut your plasmid with either one restriction enzyme or two restriction enzymes. This allows a spot for the insert to be ligated in. If you cut your plasmid with one restriction enzyme, it's called a single digest. Restriction enzymes can leave either sticky ends or blunt ends when they cut. Here is an example of cutting with a sticky end restriction enzyme called BAM-H1. You can see that it leaves overhangs or sticky ends on the plasmid, and the insert would have the corresponding sticky ends as it would be cut with the same enzyme. This is an example of another single digest, but this time with a restriction enzyme that leaves blunt ends after cutting. The restriction enzyme is called R4. You can see that there are no overhangs, but an even blunt end on each side of the plasmid. If we cut the plasmid and the insert with two different restriction digests, this is called a double digest. Usually you do a double digest with enzymes that leave sticky ends. In this case, the digest is being done with EcoR1 and BAM-H1. As you can see, the sticky ends that it leaves are different. This will be important when it comes to ligation. Recall that for this rotation, our experiment is comparing the ligation and the transformation efficiency of a larger plasmid versus a smaller plasmid. We start by setting up the digest reactions. Please refer to your protocol for Lab 1. Here are specific details for our restriction digest that you will need to add to the protocol. The large plasmid that we are using is called PBr322 and it's 4,363 base pairs. The small plasmid is PUC18 at 2,686 base pairs. Both of these plasmids are at a concentration of 25 nanograms per microliter, and the restriction enzyme that we're using to cut them is EcoR1. This is a portion of your provided restriction digest protocol. Each individual chart represents a different tube of restriction digest that we will be setting up. Roll your mouse over each individual chart to see what type of sample that tube represents. So this is an excerpt from your protocol for your restriction digest. At the very top of the restriction digest, where it says restriction digest protocol, you do need to make a more specific title. So what plasmid/plasmids are you digesting with which enzyme? So you need to add that information to the title. For this portion of the protocol where we see the different boxes where you need to fill the volumes in, this is where you need to add that extra information that was in the slide. So first of all, I just want to point a couple of things out. Each one of these boxes or charts is a separate tube. So you see I have insert tube, 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 tube. So there's actually 5 different tubes that you would be setting up. Another important point is that the total volume of each tube is 10 microliters. So you can see that each one of these volumes is set at 10 microliters. And this is important because of the buffer that we have right here. So this is a 5 times fast digest buffer. We want it working as a 1 times buffer. So it needs to be diluted by 5. So you can see here if we have a 10 microliter final volume, 1/5 of 10 is 2 microliters. So you can see that there are 2 microliters of fast digest buffer in each one of these tubes, which puts that fast digest buffer at a 1 times concentration. The other thing that is set is the volume of restriction enzyme. And I just noticed I have a small error here. So we don't have, we don't have small one. All of ours are Eco R1. So I just have the wrong restriction enzyme in a couple of these. So all the restriction enzymes are Eco R1. The restriction enzymes are set at 2 microliters, and that is set in the protocol that is provided to us by the manufacturer. So this one's Eco R1 as well, not small one. So there's only 2 volumes that we need to adjust. The first one is our plasmid DNA. And so this is where we need to add a little bit more information. So we need to add the name of our plasmid. So the large plasmid is PBR322, and it was 4,363 base pairs. So 4,363 base pairs. Base pairs. Now, this plasmid DNA is at 25 nanograms per microliter, which is also an important point. So the math to figure out what volume we need, we see here in our digest protocol that we need 50 nanograms of plasmid. So if we need 50 nanograms and our concentration is 25 nanograms per microliter, that math is pretty simple that we need 2 microliters. So that's 2 microliters of PBR 322. Our small plasmid is PUC 18, and that is at 2,686 base pairs. It's also 25 nanograms per microliter, so we need 2 microliters of that as well. So you'll just go and fill that in all the way down. Now, the one that I want to point out here is the bottom chart where we have TE buffer. TE buffer is the liquid that the plasmids are floating in. So it's the exact same as plasmid, but without any plasmid. So it's just buffer. And this is one of our controls. So we want the same volume of TE buffer as we do plasmid. So that's 2 microliters. The water now for each one is just simply the remainder of the volume. So we want 10 microliters total volume. We already have 2, 4, 6 microliters in there already. Let me just get rid of that so we don't confuse anything. Which means that the volume we want of water is 10 minus 6, which is 4 microliters of water in each one. And 4 microliters. And now we can see we have a total volume. We have 4 plus 2 is 6, plus 2 is 8, plus 2 is 10. All right, we are going to begin by setting up our 3 restriction digests. So follow along on your protocol. I'm going to start at step number 1, where I get out 3 microcentrifuge tubes. we will label them insert H2O and TE as indicated in the protocol. All right, now we'll start adding the components to each one of our tubes with our sterile pipette tips. We are going to start with, okay, so we'll begin with the water. And we'll add 2 microliters of water to each tube as we determined in the first step. So when we're adding liquid to an empty tube, we go right down to the very bottom of the tube to eject the liquid. Because I'm using the same reagent and it's going into empty tubes, I can use the same pipette tip. Okay, so that is our water. We're going to now move on to the next component, which is our 5 times fast digest buffer. There is also 2 microliters of fast digest buffer. So in here, in our ice bucket, we are going to select the 5 times fast digest buffer. One of our tubes. Now, because there's already a reagent in these tubes, we need to change our pipette tip each time. And a tip to keep your tubes straight, just move them down a row as you pipette your reagent in. That way you can keep track of which tubes you've added your reagent to. All right, so now if we look down at the next reagent, to our insert tube and our water tube, we are going to be adding 2 microliters of our plasmid DNA. So in our ice bucket, that is our P229. The P stands for plasmid. So we're just adding this to insert and H2O tubes. Once again, as I'm adding the liquid, there's already liquid in the tube, so I want to be putting that pipette tip in the liquid that's already in the tube to ensure that it's getting down to the bottom of the tube. Again, right down to the bottom of the tube. The TE tube, if you look at your protocol, you can see that we add TE buffer instead of plasmid. We are going to add the same volume, so that's 2 microliters. Again, right down to the bottom. All right, our final component that goes in all 3 of our tubes is our restriction enzyme. So that's EXBA1. So I want you to think about now what's going on. What DNA is being cut by this enzyme that's in our tube. Think about what part of that DNA is being cut by the EXBA1. Whoops, even experts drop stuff. Okay, so as you can see here, all of my liquid is in the bottom of the tube. There's no liquid on the side, so I can easily mix this by pipetting up and down. So to do that, I just pulse the plunger at the top here in between the first and second stop to mix. I technically could have done that with each tube after adding. I would have wasted less pipettes. So we're giving this a good mix. Alternatively, you can use the vortex and then centrifuge your tubes down. So these are now going to go to the 37-degree water bath for half an hour, and we'll continue on with the ligation.